My name is Aminarka Reynolds, and this is my advanced database final individual presentation. This is called DisDash. DisDash is a restaurant management system that aims to improve restaurant operations and provide a personalized dining experience for customers. The system offers features such as online and phone ordering, delivery, and a tiered customer rewards program. The company's primary goal is to enhance customer satisfaction and loyalty, which is essential for the success in the highly competitive restaurant market. It has a few functional requirements, such as a catalog of food and beverages, including detailed descriptions of their price and images, delivery with area code restrictions, ensuring timely and accurate deliveries while optimizing the delivery routes and costs. A customer reward program offering tiered rewards based on how much customers spend, including discounts on their next orders and exclusive offers. Customer profiles, which contain their contact information, order history, and preferences, such as dietary restrictions and favorite items. Inventory management that tracks the availability of ingredients and products in real time and notifies the staff when supplies are low. Employee management, which includes scheduled salaries and performance metrics, as well as training and certification rewards. For the enterprise rules, the system should provide a catalog of food and beverages that include detailed descriptions, prices, and images. The system should allow customers to place and modify their orders easily through online and phone ordering. The system should have delivery options available with area code restrictions to ensure timely and accurate deliveries, whilst optimizing delivery routes. 5, the system should create and maintain customer profiles that contain their contact information, order history, and preferences, such as dietary restrictions and favorite items. These are amongst a few. Now, we move on to the EER diagram. Now, for this EER diagram, it shows the connections between multiple tables in this restaurant database. The connection between the strong entities such as items, customers, and orders are quite apparent since many tables retrieve information from them. The weak entities such as rewards, reviews, and delivery are on the outskirts of the diagram since they inherit only a foreign key each. There are some relationship between the entities such as the customers can place multiple orders. Orders are placed by one customer and handled by one employee. Orders can contain multiple order items and each order item is linked to one item. Delivery addresses are associated with one order and can only exist if there is an order. Customers can redeem multiple rewards and each reward can be redeemed by multiple customers. Now, for the logical table derivation, the 4 strong entities are customers, orders, items, and employees, and each of them have their respective primary keys. For the weak entities, for example, the menu options entity is a weak entity because it depends on the existence of the items entity, which is referred by the foreign key item ID in the menu options table. The dietary restrictions entity represents the various dietary restrictions that customers may have, such as food allergies or cultural restrictions. Each restriction is associated with a specific customer identified by the foreign key customer ID, which references the primary key customer ID in the customers table. Now we move on to the demo. The initiation of the DisDash database is represented here. Okay. The creates DisDash 7043223 database is used in MySQL. This uses DisDash 7043223. Now for the first task, we need to create a database and tables using MS SQL DBMS. The first table that was created is the customers table, which has a customer ID, which is an integer column that serves as the primary key for the table, and is set to auto increment, which starts from 1 and increments by 1 for each new row added. It has other factors like the first name, last name, email, and phone number. Some other tables are implemented at the items, employees, delivery addresses, orders, and we have a weak entity such as order items. And this order item table has a primary key constraint on order ID and item ID, and ensures that each combination of order and item can only occur once in the table. The table also has 2 foreign key constraints, FK order item orders and FK order items item, which link order ID and item ID to the corresponding columns in the orders and items table respectively. The on-updates cascade options means that if there is a corresponding order or item, it is updated in the orders or items table, and the changes will also be reflected in the order item table. Some other tables represented or initiated are rewards, reward redemptions, menu options, reviews, promotions, restaurant tables, reservations, and table reservations with their orders, dietary restrictions, and delivery. Now, these are the four most useful indexes that we use on the table, task 2.3. The first one is placed on the customer ID column, and this index improved performance by creating queries that involve filtering or joining the customer ID column, such as finding all orders made by a specific customer. The second index is performed on the order items table, and this query is used to find all orders that include a specific item. The third one is made on the reservations table, and this query improves performance by finding all reservations made by a specific customer. And last, we have the review table, and there was a query created on it to improve performance by finding all the reviews made for a specific order. For task 2.4, we're asked to create views, triggers, and email alerts. First of all, we create a backup database so that all operations that are run on it are not affected by the main database. And this is made so that no information is lost. And then the database is not spoiled in any way. These tables are initiated just in the same way as the normal table, but these don't have any constraints and there's nothing after the data types. So we move onwards to the creation of the views. The first view is created on the customer's table, and it selects specific attributes about the customer, such as their name, phone, address, and other factors to be displayed in a view. The second view, which is created on the orders table, is meant to join it with the customer's table to include customer's email and their resulting IDs. The third view is created on the items table, and some columns, such as an item ID and item name, are chosen to be displayed in the view. The fourth view is called employee salaries, whereby it uses the employee table to select employee ID and salary columns to be displayed in the view. Triggers are also created, and the first trigger that was created is to update the order total column in the orders table with the total price of all the items that are associated with a specific order. And incorporated in these triggers are email alerts that will send an email to the recipient, which in this case is David Sampa, and it sends a subject of what is being updated or triggered, which is the update order total. And the body of this text or this email will show that the order total was updated. This happens when the trigger is set. The second trigger is for the orders table, and it updates the order status column in the orders table to be cancelled if the total price of any order becomes negative. The third trigger is used to update the item price column in the items table to the maximum option price for that item, because there's a cap on the price that should be priced for some items. The last trigger increases the salary column in the employees table by 10% for any employee who has processed orders with a total quantity greater than 0. So this brings us to the end of our views, triggers, and email alerts. Now we have the stored procedures that are used to populate the entities in this database. For example, the customers database or the customers table is populated by adding entries for the first name, last name, email, phone number, and address. And for each table, there are 10 entities or 10 examples that are used to populate these tables. The items table has item name, description, and item price. The delivery addresses have city and zip code, whereby the zip code is used to create a constraint on which deliveries can be made or not, depending on the zip code that the customer has. Table reservations, yes, table ID, customer ID, reservation date. The employee table, dietary restrictions table, which has the customer ID and the restriction type. If the person is gluten-free, vegan, vegetarian, nut-free, we need to know this information before we serve any food to them. There are some things like the promotions table, which works on employees, reward redemptions, which are rewards gotten by customers when they purchase more than one item. or more than a certain amount of items. There is a rewards table which has the reward name and the reward points. So after some calculations are made and you get some certain rewards, you get specific rewards such as you have a free drink at 100 points, and at 700 points, you have a 25% discount on anything that you buy. Menu options, restaurant tables, table orders, and the rest of the tables are populated using the stored procedure. And at the end, the execution statements for these stored procedures to populate the entities are down here below. Lastly, we have the 6 queries, which are written with stored procedures as asked by task 2.6. The first stored procedure joins the customers and orders table and it stores the results by order total in descending order. It returns only the customer's first and last name and the order total for each order. The second one stores procedures that return the total number of orders for each customer who has placed an order. The third one is a stored procedure that returns the top 5 best-selling items, including the item name and the number of items it has ordered. The fourth stored procedure returns the average salary for employees who have a job title of manager. The fifth one returns all orders that have a total greater than 50 and were placed by a customer with a last name which starts with S. This was specificity conditions. The last stored procedure returns the total number of reward points redeemed by each customer. And this includes the customer's first and last name. Finally, we run the whole database. And we see that everything runs perfectly and everything is executed well. Now, for the showcase of the population of some of the tables, we go into database, this dash, programmability, some stored procedures. And then, for example, we can look at the customer order counts. And this is a stored procedure, which right now clearly shows that the customer and the amount of orders made so that redemption points can be attained and all calculated by the customer. The second one that we have are redemption totals. Redemption totals by the customer. This stored procedure returns back points which are received by individual customers depending on the amount of product bought. As you can see, Bob has the highest since he spent the most. This brings me to the end of my presentation. Thank you.